Organic chemistry, lab demonstration. General safety rules. Listen to or read instructions carefully before attempting to do anything. Wear your lab coat and safety goggles to protect your eyes from chemicals, heated materials, or things that might shatter. Notify your teacher if any spills or accidents occur. After handling chemicals, always wash your hands with soap and water. During lab work, keep your hands away from your face. Tie back long hair. Know the location of the fire extinguisher, fire blanket, eye wash station, and first aid kit. Keep your work area clean. Take to the lab station only what is necessary. It is suggested that you wear glasses rather than contact lenses. Never put anything into your mouth during a lab experiment. Clean up your lab area at the conclusion of the laboratory period. Glassware safety. Chipped or glassware should not be used. Show it to the teacher. Broken glassware should not be disposed of in a classroom trash can. There is a special glass disposal container for it. When pouring liquids into glassware, make sure the container you are pouring into is resting on a table at least a hand's breadth from the edge. If a piece of glassware gets broken, do not try to clean it up by yourself. Notify the teacher. Do not place hot glassware in water. Rapid cooling may make it shatter. Chemical safety. Wear protective goggles whenever heating or pouring hazardous chemicals. Never mix chemicals together unless you are told to do so, and then only in the manner specified. Never taste any chemicals. You should never taste anything in the lab. If you need to smell the odor of a chemical, waft the fumes toward your nose with one hand. Do not put your nose over the container and inhale the fumes. Follow the instructions of your teacher when disposing of all chemicals. Wash your hands after handling hazardous chemicals. Heating safety. Use tongs and/or protective gloves to handle hot objects. Never reach across an open flame or burner. Always point the top ends of test tubes that are being heated away from people. When heating a test tube, move it around slowly over the flame to distribute the heat evenly. Only glassware that is truly dry should be heated. Heat glassware by placing it on a wire gauze platform on a ring stand. Do not hold it in your hand. First aid. Injury, burns. To do. Immediately flush with cold water until burning sensation is lessened. Injury, cuts, bruises. To do. Do not touch an open wound without safety gloves. Pressing directly on minor cuts will stop bleeding in a few minutes. Apply cold compress to bruises to reduce swelling. Injury, the eyes. To do. Flush eyes immediately with plenty of water for several minutes. If a foreign object is lodged in the eye, do not allow the eye to be wrapped. Chemicals in organic and pharmaceutical laboratories. Labeling of chemicals. All chemicals present in a research or training laboratory must be labeled appropriately. This is simply a very critical safety rule. Therefore, students should never use a chemical container without a label on it. Storage of chemicals, chemical cabinets, and laboratory registration. There are rules for the storage of chemicals in laboratories. Some of them are related to the safety guidelines, and some of the rules are created to easily find a chemical in a laboratory. Proper storage of chemicals. Store by hazard classification. Flammables. Flammable storage cabinet or fridge. Corrosives. Acid-base storage cabinet. Oxidizers. Away from flammables. Check SDS for storage requirements, such as temperature and light. Chemicals of concern that are commonly used in labs. Explosive. May explode as a consequence of fire, heat, shock, or friction. Chemicals with this label should be kept away from potential ignition sources. Toxic. The substances are very hazardous to health when breathed, swallowed, or in contact with the skin, and may even lead to death. Biohazard. Biological substances that pose a threat to human health. Dangerous for the environment. Those chemicals cause danger for the environment. Highly flammable. Flammable when exposed to heat, fire, or sparks, or give off flammable gases when reacting with water. Ignition sources should be avoided. Harmful. When taken up by the body, these substances cause slight damage. Corrosive. May cause burns to skin and damage to eyes. May also corrode metals. Oxidizing. Burns even in the absence of air and intensify fires in combustible materials. Should be kept away from ignition sources. General requirements for chemical laboratory. Benches and hoods. laboratory glassware, porcelain and metal equipment, various laboratory glassware, Erlenmeyer flask, single neck round bottom flask, two neck round bottom flask, three neck round bottom flask, filtration flask, beaker, graduated cylinder, volumetric pipette, bulb pipette, test tube, glass rod, funnel, thermometer, Buchner funnel, condensers and addition and separation funnels, condensers, fractionating column, and separation funnels, adapter, metallic, plastic, and rubber tools, ring stand, clamp, tongs, magnetic stirrer, pipette filler bulb, spatula, wash bottle, rubber stopper, pipette, micropipette, micropipette tip, balances. Balances are the starting points of most of the practices in chemistry laboratories. In order to accurately weigh and transfer liquids and solid organic compounds, balances are utilized. Heaters. Heaters are so important in organic synthesis studies because some of the organic reactions require activation energy to reach to transition state and to yield the product. Furnaces or ovens. Ovens are routinely required in organic synthesis studies to dry the solid reagents and particularly reaction products. These instruments are made up with an electronic system to set up desired inside temperature. Depending and particularly knowing the melting point of organic compounds, ovens are used to dry materials. Desiccators. Desiccators are instruments to dry solid compounds in organic and pharmaceutical chemistry applications. They are particularly used to remove water residues in solid organic substances. Another advantage of desiccators is that they are also available to dry substances thermally unstable and therefore should not be heated to dry. Other instruments used in organic laboratories. There are other instruments employed routinely in organic chemistry practices: UV ultraviolet spectrophotometers, HPLC high pressure liquid chromatography systems, GC gas chromatography systems, MS mass spectroscopy systems. Classification of organic research studies, literature search, sources to obtain chemicals, synthesis studies, yield calculation, workup purification studies, qualitative and quantitative analysis, instrumental analysis, introductory level, workup and purification studies, melting point. Melting point for an organic substance is the temperature at which it changes from solid state to liquid state. Melting point determinations have importance in various applications, such as making a comparison with the literature data to observe the same temperature, having a very rough idea on the purity of a substance. There are much more available and accurate methods applied to decide it. To identify the melting point of a substance that is originally synthesized. Solubility. Solubility is the degree of dissolution of a substance in a solvent, the solubility of a liquid substance in another liquid matter, miscibility and immiscibility. Like dissolves like. There are lots of interaction types that might take place in the solution of a substance in a liquid. The organic molecules cannot dissolve in water because long carbon skeletons, absence of polar functional groups, absence of heteroatoms, absence of ionic structures, hydrophobic character. Miscibility. Miscibility of organic solvents is quite important. For instance, some reactions utilize more than one organic solvent to conduct a reaction as reagents or to increase the solubility. Some workup and purification studies also require the employment of more than one solvent. Extraction. It is a separation technique. Depending upon the system, extraction can be categorized into two groups: solid-liquid extraction and liquid-liquid extraction. Solid-liquid extraction simply aims to extract the material from a solid mixture into a liquid. For example, the material inside the dried leaves extracted into hot water. Assume a solid mixture of benzoic acid and sodium benzoate. If you treat this mixture with water, sodium benzoate readily dissolves in water, whereas benzoic acid has very limited solubility. Liquid-liquid extractions employ the solubility difference of an organic compound in two immiscible liquids. Extraction. Separation funnels are utilized for liquid-liquid extraction. Immiscible solvents separate in funnel such that the heavier, the higher density stays at bottom. Drying of liquids. Following the extraction process, in general, the organic phase is evaporated to gain the organic compound. In practice, most of the organic solvents have the ability to dissolve some amount of water as well. The amount of water transferred into organic phase changes depending on the organic solvent used. In general, anhydrous sodium sulfate and anhydrous magnesium sulfate, anhydrous calcium chloride, anhydrous copper sulfate, and anhydrous calcium sulfate are used to get rid of this water from liquid. Filtration. Filtration is one of the most applied processes in organic and pharmaceutical chemistry practices. In general, filtration is categorized into two groups: gravity filtration and vacuum filtration. Gravity filtration is the simple form of filtration. It is routinely applied in training laboratories. Gravity is the only driving force in this type of filtration. Vacuum filtration is another filtration type. The only difference is the employing of vacuum as a driving force of filtration. Therefore, vacuum filtration is much faster than gravity filtration. Distillation. Distillation is an old-known separation and purification technique particularly applied for liquids. It is based on a system consisting of both heating and cooling units. Simple distillation can be used effectively to separate liquids that have at least 50 degrees Celsius difference in their boiling points. Fractional distillation. Liquids that have different boiling points and do not make azeotrope mixtures can be separated employing the fractional distillation technique. The difference between fractional distillation and simple distillation is the employment of a fractionating column. Steam distillation. This type of distillation is generally assayed for liquids that have high boiling points and decompose at high temperatures less than their boiling point. The steam distillation system applies the in-situ generation of steam and applying it directly into the material to activate it for distillation. Vacuum distillation. It is also referred to as low-pressure distillation. Boiling point of an organic substance depends on several factors, including the pressure. The vacuum application to a distillation unit would be enough to decrease the pressure inside the system, resulting in the boiling of a liquid compound at temperatures lower than its regular boiling temperature. For instance, dimethyl sulfoxide has a relatively high boiling point, around 190 degrees Celsius. Vacuum application to the system physically takes down the boiling point of dimethyl sulfoxide. An effective vacuum can even take it to less than 100 degrees Celsius. Rotary evaporator. The main principle in a rotary evaporator is the distillation or the removal of an organic solvent. This is done in the presence of heat and vacuum in order to evaporate an organic solvent well below its boiling point temperature. As a result, it saves time and energy. Thank you for your attention.